Quiz, the second of the subject topics for the individual quiz.
Yes, the individual quiz will be over anything in the first three chapters, and today's group quiz covers through the third chapter.
Is there any specific study guide you put out?
I think that the study guide is the reading and homework suggestions that I've already put out, and you'll now have two group quizzes under your belt to study from. Okay, I'll answer the question I asked. We're dealing with nomenclature. The end of this our last time. You know, a one carbon thing stuck onto something else, that long bond is implying that it's stuck onto something else. A one carbon thing stuck onto something else is called a one carbon thing stuck onto something else is called methyl. CH4 is methane, but remove a hydrogen and use that bond to stick it onto something else, that's now a methyl group. Drop the A and E and add YL. If you have a two carbon thing stuck onto something else, that's an ethyl group. If you have a three carbon thing stuck onto something else, that's a propyl group. If you have a three carbon thing stuck onto something else, there's only one way you can stick one carbon onto something, stick it on there. There's only one way you can stick a two carbon thing. Doesn't matter which of the two carbons is stuck onto the other thing, it's going to be the same deal. But with three carbons, there's more than one way. We could stick it onto our parent chain via an end carbon, or we could stick it onto the parent chain via not the end carbon. We call this a propyl group. We call this isopropyl. The idea being it's an isomer of the propyl group. The propyl group obviously has three carbons and has how many hydrogens? Seven. The isopropyl group obviously has three carbons and has how many hydrogens? Seven. They're therefore isomeric. So we call this propyl. If all you say is propyl, the assumption is that we're dealing with a straight chain hooked on the end. Isopropyl, we're hooked on the middle. Sometimes folks will call this normal propyl. We usually don't write the whole word normal, we just put N for normal. So if you see that, that's just emphasizing the fact that it's a straight chain hooked on the end. But if you see just propyl, the implication is that it's just a straight chain guy hooked on the end. As we get to bigger guys, say 4, the possibilities for how this could be attached to a parent chain increases. We could hook it via an end carbon onto a parent chain. We could hook it not via an end carbon onto the parent chain. And the 4 carbons don't even have to be in a line. There's no way for 3 carbons not to be in a line. But 4 carbons don't even have to be all lined up in a row. So arranged this way, we could hook it onto a parent chain via one of the outside carbons. Or we could hook it onto the parent chain via the inside carbon. So there are 4 different ways. This is a butyl group, this is a butyl group, this is a butyl group, this is a butyl group. What do you think we call this one? Yeah, N-butyl for normal butyl. With propyl it was easy, we only had one alternative. It being an isomer of, we called it isobutyl, done. But now we have 3 alternatives. They can't all be isobutyl, even though they're all isomers of normal butyl. Only one of them can get isobutyl status. That happens to be this one. This is called an isobutyl group. For reasons which we'll explain in a second. This is called a secondary butyl group. Often written just sec-butyl. And it's not too dorky to say sec-butyl out loud. But we usually say secondary butyl out loud. No, we hardly ever write secondary, we just write sec-butyl. And this one tertiary butyl. We often just write it T-butyl. We often just say T-butyl. No one but kind of a dork would say tert-butyl. I take that back. We say it every once in a while, but not commonly. T-butyl, tertiary butyl is usually what comes out of people's mouths. Writing tert-butyl is common. Writing T-butyl is very common. And on secondary butyl, just writing S-butyl happens sometimes. And most people write the whole sec-butyl. All of the above are okay. Now here's where these latter 2 names come from. Just for grin's sake, we'll do this, not that it's all that important. Okay, here we have a compound, bunch of carbons in this sucker. All carbons can be defined as being primary carbons, secondary carbons, tertiary carbons, or quaternary carbons. And it's quite straightforward. You are a primary carbon if you are bonded to only one other carbon. So how many primary carbons in this molecule here?
6, 7, 8, 9.
5. 5 primary carbons. This guy is a primary carbon. Ooh, note that. What came out of my mouth was primary carbon. What I wrote was a 1-degree carbon. Don't ever say a 1-degree carbon or a 1st-degree carbon. That is definitely dorky. Say primary carbon, but we often write it this way. He's a primary carbon. He's a primary carbon. He's a primary carbon. He's a primary carbon, and he's a primary carbon. Those are all the carbons that are bonded to only one other carbon. Somebody go out on a limb and suggest what a secondary carbon is. One that is bonded to 2 other carbons. As I look up here, how many secondary carbons do I have in this guy? 3 secondary carbons. Okay, bueno. He's a secondary carbon. He's a secondary carbon. He's a secondary carbon. They are the guys that are bonded to 2 other carbons. A tertiary carbon is one that is bonded to 3 other carbons. How many tertiary carbons in this guy? There you go. This guy is our only tertiary carbon. He's bonded to 3 other carbons, and a quaternary carbon is one that's bonded to 4 other guys. This guy is a quaternary carbon. although who cares? That ends up being not important. But distinguishing between primary, secondary, and tertiary carbons is very important. So, this is called secondary butyl because the carbon that is bonded to the parent chain is bonded to two other carbons in the butyl group. So we're hooked on via a secondary carbon. This is called tertiary butyl because the carbon that is bonded to the parent chain is bonded to three other carbons in the butyl group. In other words, it's a tertiary carbon. Normal butyl, the carbon that's bonded to the parent chain, is a primary carbon. And isobutyl, the carbon bonded to the parent chain, is also a primary carbon. So we can't call this like primary butyl because that's also a primary butyl. So kind of by default, we give, this is the only possible secondary butyl, this is the only possible tertiary butyl. This guy therefore gets isobutyl status. Okay. We could go on to a 5-carbon side chain. 6, 7, and so on. The possibilities increase dramatically. Don't worry about it though. I will only hold you responsible for, other than, I can hold you responsible for a normal anything, but other than a normal blank-ol side chain, I would only hold you responsible for isopropyl, isobutyl, secondary butyl, and tertiary butyl. No others. You need to know those. Okay, who's this? Longest continuous chain? Octane. 1, 2, 3, 4, 5, 6, 7. Heptane. It's octane. Those of you that said octane, absolutely correct. The longest continuous chain is that. The fact that I didn't draw it a nice little straight line is absolutely irrelevant. Who's stuck on?
Methyl 3 and an isopropyl 5.
Yeah, I've got a methyl group stuck onto this sucker. I've got an isopropyl group stuck onto this sucker. UPAC says we alphabetize.
So 5 isopropyl, 3 methyl octane.
Actually, I'm not 100% sure what the actual full UPAC rule is. I do know that people disagree on isopropyl. Do we alphabetize with the P for propyl, or do we alphabetize including the prefix I for iso? Most people include the I for iso. But I can't sit here and tell you that I'm 100% sure that's even the UPAC rule. One thing that tells you is that I can't sit here and tell you that I 100% don't care. But I'm pretty sure that the official rule is we use the iso. So isopropyl before methyl. And as Jonathan pointed out, we start numbering from this end. Which puts the methyl on carbon 3 and the isopropyl on carbon 5. Why did I start numbering from this end?
That's where the first decision is.
Yeah, it puts them on lower numbered carbons. Had I numbered from this end, we'd be on 4 and 6. 3 and 5 are lower than 4 and 6, so there we go. quiz time. Okay, have fun.